All right, let's talk about something that's a huge deal in the world of cloud architecture. How do you build a system that's not just fast, but reliable for users absolutely everywhere on the planet? Well, the answer, a lot of the time, is something called a multi-cluster service mesh. Sounds complicated, I know, but we're going to break down exactly what that means and how you'd actually go about building one.
So, picture this. Your application, your service, it's a massive hit, which is awesome, right? That's the dream. But now you've got this new problem, a good problem. You need to go global, serve customers in different continents, and give every single one of them a fast, snappy experience. That kind of growth, though, brings a whole new world of architectural pain.
So here's our game plan for today. We're going to start by digging into the core problem. Then, we'll see how a service mesh like Istio can literally bridge the gap between regions. After that, we'll explore a really critical choice you have to make about your control plane, and then, this is the fun part, we're going to simulate a total region failure to see how the mesh holds up. And finally, we'll wrap it all up with 4 essential rules to think about before you even write a single line of code.
Okay, let's make this feel a bit more real. Instead of just talking theory, we're going to follow the story of a fictional company. Let's call them Nomad Travels. We'll see how they handle the growing pains of scaling their architecture from just one region to a truly global setup.
You know, in the beginning, life is pretty simple for Nomad Travels. They've got everything running in one Amazon EKS cluster. That's just Amazon's managed Kubernetes service, smack in the middle of the United States. Everything's working, the customers are happy, and the whole system is pretty easy to manage. But as Nomad Travels gets more and more popular in Europe, they start hearing the same complaint over and over. Latency. It's just too slow. And you can't really argue with the speed of light, right? So the logical next step is to get the services closer to the users. They decide to deploy a second, brand new cluster, this time in the EU.
And bam, this is where the complexity just explodes. Suddenly, their front-end services running in Europe need to talk to their main databases and back-end services that are still running back in the US. So the big question is, how do you manage that connection? How do you make it secure and reliable and observable when you're literally sending traffic across an ocean over the public internet?
This exact scenario is precisely the problem that a service mesh was designed to solve. So for our next section, we're going to look at how a tool like Istio gives you everything you need to build a secure bridge between these two otherwise isolated clusters.
So what even is a service mesh? The simplest way to think about it is as a separate, dedicated layer in your system that's only job is to handle how services talk to each other. So instead of every service needing to figure out encryption and retries and routing, the mesh just handles all of that for them. It's a game changer.
And this is where the real magic of Istio comes into play. It has this amazing ability to kind of stretch itself across both the US and the EU clusters. It makes them act as if they're all part of one single logical network. It's like you're creating your own private, intelligent, secure highway that just happens to overlay the physical distance. Okay, so we've decided we want a mesh. Awesome. But now we hit our first major architectural decision. How are we going to set up the brain of this mesh, what we call the control plane, to manage our services across 2 different regions?
Yeah, the air traffic control analogy is perfect here. The control plane doesn't actually carry any of the user data itself. That's the data plane's job. But it's the control tower that tells all your services where to go, what the rules of the road are, and who is allowed to talk to whom. It's the director of the whole show.
So you basically have 2 main models for setting up this control tower. On one hand, you have the replicated model. Each cluster gets its very own control plane. This is fantastic for fault isolation, right? If one control plane goes down, the other region is totally ineffective. The downside? It's way more complex to manage. On the other hand, you have the shared control plane, one brain to rule them all. This gives you a beautiful single pane of glass to see everything, but you just created one massive single point of failure. It's that classic engineering trade-off, resilience versus simplicity. Now, no matter which control plane model you choose, you absolutely need this one component, an east-west gateway. Think of it like the secure checkpoint for any traffic that needs to leave one cluster and get into another. It's the only way services can talk across regions, and it makes sure that all that traffic flying across the Atlantic is encrypted and routed exactly where it needs to go. So, we've designed this really sophisticated, powerful multi-cluster mesh for Nomad Travels. It looks fantastic on a whiteboard. But what's the real payoff? Let's find out what happens when things go very, very wrong. Let's put this thing to the test. Okay, this is the magic trick. Under normal operation, everything's great. Traffic is flowing happily between the US and the EU. Then, disaster. The entire US region goes down. It's just gone. Now, without a mesh, this is a code red emergency. Pagers are going off, everyone's scrambling. But with Istio, the mesh just detects the failure, and automatically, with zero human intervention, it reroutes all global traffic over to the healthy services in the EU cluster. The failover is complete, and the best part, your users probably didn't even notice. That is the kind of resilience you're paying for with all this complexity.
We've seen the how, and we've definitely seen the why. But, the most important question for any good architect is actually if. Should we even be doing this? Adding a multi-cluster service mesh is a huge operational investment. So, before you jump in head first, let's cover 4 guiding principles.
Let's walk through these 4 rules. I want you to think of these as a sanity check, a way to protect yourself from adding complexity just for the sake of it.
Number 1. Always start with the absolute simplest thing that could possibly work. Can you get by with a single cluster? Do that for as long as you can. 2. Have strong observability first. If you can't see what your services are doing now, a mesh is just going to hide the problems under a new layer of abstraction. 3. Really know your cloud provider's failure domains. Will a mesh actually protect you from the kind of outage you're likely to have? And maybe most importantly, number 4. Don't add a mesh just because it's cool new tech. The operational overhead is very, very real. Make sure you have a concrete business need, like global latency or disaster recovery, that truly justifies the cost.
And that's really the ultimate takeaway here. We've walked through the architecture, we've seen the incredible benefits. You now have a high-level blueprint for how to build a global, resilient system. But the real work of an architect isn't just knowing how to build it, it's knowing when to build it. So the question I want to leave you with is this. Is the cost of this complexity really worth the value it brings to your business? That's the question you have to take back to your team.